All right, now we're going to talk about circular motion and gravitation for a few minutes. So, with circular motion, we've got an object that's moving in a circle, okay, and it's moving at a constant velocity value, but it's changing direction. So, that ends up meaning that it's accelerating. So, we've got velocity that follows around the circle, tangent to the circle, and then we've always got a force pulling us inward to the center of the circle. And that force is called centripetal force, directed towards the center of the circle. The object has a constant velocity value, but the velocity is changing, the direction is changing. Remember, velocity is a vector, so it's got a number value and a direction. And so that means that the object's actually accelerating as it's moving in this circular motion because the direction is changing. Okay. And we learned that when we're accelerating in circular motion, there's a specific equation we can use for centripetal acceleration, and that's our velocity squared divided by the radius of our object. Okay. So, what's the centripetal acceleration of a yo-yo spinning in a circle at 4 meters per second on a string that's 1.2 meters? We can just take our 4 meters per second, we're going to square that, and then we're going to divide that by our radius of 1.2, and that'll give us our acceleration for this object. So this is like just a really specific acceleration. Just for this type of circular motion where we use this equation. So I got 13.3, and that's my acceleration of my object. 13.3 meters per second per second. Still in units of meters per second per second. This is still an acceleration, just like the other accelerations we've looked at. It's just only applies when you're in this type of circular motion. Okay. Okay, and then we also talked about gravitation. We have this equation for force of gravity between two big objects. So this is between like the Earth and the Moon, for example. And I need some more space, I feel like. This is where we talked about what I called the factor of change. And then like our rule of ones. Okay. So if we want to know how the force of gravity changes, if we change something like one of the masses or the distance between them, then we use these factor of change and rule of ones. Your force of gravity of your two objects, okay, it depends on their mass. So say this was the Earth and the Moon. You'd have the mass of the Earth times the mass of the Moon, and then you're dividing that by the distance between them. It's really the distance between the centers of the two objects. And you have to square that. That's really important because that's part of the equation. Okay, so I got two masses, I got a distance between them, and the force of gravity depends on their masses multiplied together, but it also depends on the distance between them, and then that's squared, and that's divided. Okay. So let's go through some examples. When the distance between two objects increases, okay, so here this number is going to increase. That means that the force is going to decrease. As they get farther apart from each other, they exert less force on each other. When the mass of one of them increases, the force between them, so imagine one of these numbers gets bigger, that means this force is going to get bigger, okay? So we say that mass and force have a direct relationship, right? That means if the mass doubles, the force is going to be double. And we can do that using the rule of ones, okay? So we'll pretend everything's equal to 1, and then we're going to double one of these masses. Let's say we double M1. So now we're going to have 2 instead of 1 here, times 1 divided by 1 squared gives me a factor of 2 that my force of gravity is increased. My force of gravity doubled because this mass doubled. Okay. So mass and force have a direct relationship. And if mass doubles, one of the masses doubles, force is going to double too. With distance, it's a little different because we're dividing by distance, first of all, and we're dividing by a square of distance. So that's actually what's called an inverse square relationship. So if distance doubles, let's say, okay, so now we're going to do our same rule of ones. And now we're going to say that distance doubles. So we've got 1 times 1 on the top because our masses didn't change. And we divide that by 2 because our distance is going to double, but we have to square it. Okay, so that gives us 1 over 2 squared, which is 1/4. That means that if the distance between these two doubles, say if it goes from like this to like this, for example, that force is going to be decreased. It's decreased by an inverse square. Okay, this being on the bottom of this equation and then being squared has a really big impact, like mathematically, on this force. So we end up with our force being 1/4 what it was. Okay, so if it was 1, now it's become 0.25, like it's gotten that much smaller. So if distance doubles, the force will become 1/4 what it was. And you can do this rule of ones with any combination. Like you could change both masses, you could increase or decrease the distance. You can change more than one thing. You just do the same type of math here. You just substitute whatever changed for however much it changed, and then do the math out and see what your factor is. This is your factor of change, your 2 here or your 1/4 here. That tells you by how much does this force of gravity change if I double a mass or triple a distance or whatever. Okay. Okay, so that's circular motion and universal gravitation.